Hello, it's Duncan. In last week's episode we looked at data-oriented programming, essentially the art of using maps and lists. We wrote a couple of utility functions to extract data from maps and use those to gradually migrate from maps to strongly typed classes. We stopped 2 levels deep though, so today we'll learn how to extract data from arbitrary paths. On the way we'll learn to manage variable argument lists with the fold operation, a nice trick to avoid ending up with an empty argument list, and see how easy it is to build data using maps and lists. We left last week having created PropertySet, which is just a type alias for map of string to any question mark. And map of string to any question mark is our way of representing a JSON object. So the keys in a JSON object are always strings, but the values can be anything really. And we were using that to parse some JSON. It's the response from the Google Places API, and it looks something like this. Let's put that over there. And if we ask Jackson to read this JSON as a property set, which is a map of string to any question mark, then what we get is nested property sets and arrays and primitives. So at the top level we have a property set with just places in it, and then we have an array, well that maps to a Kotlin list, and inside that we have more property sets, where this one has a name which maps to a string, ID maps to string, types maps to array of string, and so on. And we saw how we can start by just indexing into those maps, and gradually make our way to data types like place and address component, which wrap the property set and pick the data that we're actually interested in out as fields themselves. And we wrote this required, which looks 1 or 2 levels deep from a map to find a property. Now we were very much spitballing the implementation of this to see how nice it feels, and to me at least it does feel quite nice. So I think what I'm going to do is I'm going to add some tests for these functions, and that will allow us to extend them a bit. So I've created a property set tests. Let's add ourselves a test. And for the moment we're just describing how we think this thing works. So I don't really have a good name, I'm going to call it test. Now property set is just a map of string to any, so how do we build one of those? And of course creating data is the other side of data-oriented programming. We're probably not just extracting it, so it'd be good to get some practice in. So let's create ourselves a val, we'll call it property set, and we could start with an empty map. And if we tell IntelliJ that this is a property set, then it'll know the type of that map is string to any. Now, of course, any key we try to get out of this property set, it can't give us, and so it's going to have to throw. So we can say expect throws. Now, what do we expect to be thrown? Well, this error for cannot find key, I suppose, over here. I think actually we might do a bit better. This error throws an illegal state exception, but as Lucas, I think it was, pointed out in the last video, there is actually getValue on map, and that throws a no such element exception. That sounds like a bit of a better idea. So let's say we're going to expect a no such element exception if we try and say property set required for practically anything. Let's see whether that's true by running the tests. And it is, and I think we could probably ask questions about that. So we can say that the message is equal to, and we'll put in an empty string in here to find out what we actually get. Run that, and the answer is key any is missing in the map. Well, I think that's a good description. We might not want to tie ourselves to a specific error message forever, but that's not bad. And I think that means I can take that away. Now note that that doesn't compile, and the reason is that getValue can still return null if there is actually a key and it's assigned to null. And as our property set is a map of string to any, that can happen. So I think we're going to have to put our error back here and say that now the error is, it's not missing, I think it's probably that key is null. That compiles and works. But we might want to write a test for that as well. So I think we'll have here, this is empty map has no keys. And we'll duplicate this to say null key throws. So now if we start with not an empty map, but a map of key to null, and we try and get key, We don't expect a no such element exception, but let's run to just check. That's true, so we do expect this illegal state exception, and we expect our message, which was key is null. Is that right? Good. Now let's try the happy path. So we will duplicate this test, and we'll try string value. So in this case, we'll say key to value, and we don't expect an illegal state exception in that case. So let's take that away, and we'll say expect that property set required given key, and we need to tell it that we expect a string because it's got no other clue, is equal to the thing that you put in, which is value. Is that right? Yes, it is. And now we should be able to say what happens if we don't have a string, we have something else. Let's use an int value. So if we now say we put in key to 42, then when we get out, we expect 42. Now note the type checking works here. That strict tells us that we were trying to get out a string and we try to compare it to an int. But what we actually need to do is we need to tell it that we were trying to get out an int. Run that. Splendid. Now this begs the question of what happens if we try and get out the wrong type of thing. I think we'll take this one here, which has got a throws for us. We will cut that and we will put that in here. So this is wrong type throws. And so now if we say let's put in a value, but we'll get it out as a string, see what we actually get by running this. Did I say string? I meant get it out as an int. Run that to see what we get. And we get value for key is not a class Kotlin int. Well, that's not a bad error message, and I think we might as well just say that's what we see. Run that. Good. Now I don't know about you, but I'm having trouble with both of these sides at once, so I'm going to, I think, maybe just reformat this a bit. So we'll pull that down there and that down there, and then this one, I think we'll put these arguments on separate lines, maybe better. And then pull the message down there. Well, who knows? I can read that at least. Right, how about lists? They're important to us, so I think we'll just duplicate this one. Interestingly, the tests seem to have got separated a bit. So this one could be a test, and this is going to be a list value. And so we'll say map of key to list of, well, we've got a number, so let's go with numbers, 42 and 99, like that. And if we say that we want that out as a list, I think actually we could say any, but we'll say list of int. That should be our list of 42 and 99. Is that true? It is. I'm interested to see how far the casting goes. I'm going to duplicate this, move it down here, and have a look at the wrong list type. Just see what actually happens. So I put in a list of ints, but I wonder what happens if I say I want to get out a list of string. Now obviously we can't compare that to a list of 42 to 99 because that's not a list of string. So I'm just going to take the assertion away, comment it out, and just see what happens. And here you can see the cast has actually succeeded, and I guess that's because of erasure in the JVM. The JVM has no way of knowing that we require a concrete type of string rather than int, or int rather than string in here. So that's a little bit strange, but I think maybe we're just documenting it here. This is wrong list type, doesn't throw, and that's effectively a feature of Kotlin on the JVM, I think. I think we might say that we could check the size, and that actually is equal to two things. Is that true? Yes, it is. So we've got two things in the list, but we had the wrong idea about what their type is. Okay then, we have another method we want to test, and this is this one that takes two keys and assumes we've got nested maps. So let's try to test for that. Let's going to look something like this one. So let's just duplicate that. And this is, I think, maybe path of 2 keys. So we need to set up a property set, and we can say it is key to, and inside here we need another map. So this is going to be a map of, drop it down there so you can see it, and this one is going to have, say, key to value. And note that we can build nested property sets just by nesting our maps. And so how do we get things out of here? Well, we know we've got a value in here, so we are going to have a, say, required string, and that's a key, comma, key 2. And that we expect to be is equal to our value. Run that. And that's true. And now there are 2 ways that we could fail. And I think maybe I'm going to just write them in here. We could fail because key 1 isn't there, or because key 2 is there. So let's take what failure looks like. And it's this one here. So if we take that and put it in here, and this is no such. So if we go to our property set and we ask for something that isn't required in the first place, then we should say key no such is missing the map. That's true. But we should put in key 2 in here because we're testing the 2-argument version. That's true. Duplicate this and say, even if we were to go to key that does exist and then look for no such, we should get the same thing. Now I think maybe a truly friendly error message would tell us the path that we were looking for and where it failed, but I think we'll leave that as a stretch target because I want to move on to 3 keys. So let's create ourselves a test, path of 3 keys. And instead of just adding another function, we're going to change this to work with varargs. So let's set ourselves up some data. We'll duplicate that, take it out of there, put it into there. And now we've got a map of key 2 to value, but what we're going to put in here is key 2 to map of key 3 to value. Add an extra bracket. Just see how Kotlin wants to lay that out. Yeah, that's okay. So what we want to be able to say now is that if we did something like this against this property set with key 1, key 2, and I messed that up because that should be key 3. I expect you to be shouting at me. Key 3 should be value. And we can't tell because we don't have a function like that. So let's create ourselves one, and we'll say we'll duplicate this, and we will have a vararg keys, each of which is a string. I'm just going to do that for now so we can check that everything compiles. And it does compile, but it doesn't work because of this to do. Okay. Now then, a good general tip for working with varargs is immediately to write a list version. So we should be able to duplicate this and say that we want a version that takes keys as a list of string that isn't vararg, and delegate this one to be required given our varargs of keys to list. Now then, to me at least, the easiest way of thinking about this one is that we have 3 cases of the keys. So we have when, if our keys is empty, or we can't do anything for you, you haven't told us where to look, so this is going to have to be an error of no keys supplied. Now the next case is that the keys size is 1. If we're down to 1 key, we've got the same thing as we've got here, so this is required with that 1 item, so that's keys single. Otherwise, where we want to take the first key and use it to give ourselves a property set, so that's going to be required property set with keys first, and now we want to call ourselves with the rest of the keys. So this is keys drop 1. And you'll see a problem here, which is that inline functions can't be called recursively. I guess the compiler is actually going to put this bytecode into the call site, and it can't do that again and again and again and again and again. Now there are two solutions to that problem. One is to make this not an inline function, but a function that takes the type that it's looking for, this t, as a class object, and then we could have a function on the outside that has the reified t and is inline, and uses that to work out the class object and pass it into here. That's a bit of a pain, to be honest. I think we might end up doing it eventually, but maybe not now. So let's see if we can think of this another way. We could have moved the size of the list into here as the subject. So that's keys dot size, and then that would have been 0 or 1. That obviously still doesn't compile, but when we're trying to do something recursively on a list, we can normally express that as a fold. The problem here though is that we don't want to fold over every item because the last item is different. Every item but the last item we want to use required property set, but the last item we want to use this required. So we'll leave this case for now, and we'll say in this else we're going to take our keys and we are going to drop the last one. So that's our special one. And now we're going to fold. And fold takes an initial thing, and the initial thing we're going to pass into that is this. You'll see why in a minute. And a fold takes two things. It takes an accumulator and an item from the list, and an item from the list is a key. If we just ask for the types of these, it'll show them to us. So that's a string, which is a key, and this thing is our map of string to any, which we know to be a property set. So we're starting with the first property set, the outside one, this, and we are going to ask the accumulator, starting with this one, to find the required thing with this key, and that needs to be a property set. And then this thing will be put back up as the accumulator for the next one, and the next time we'll get key 2, and so on and so on. For the very last one, we then say that's a required with the keys last. Now you'll note that that actually compiles. So let's see whether it works. And my goodness, it does. Now I'm not sure I have a great deal of confidence in this, but in fact my confidence will be increased by removing things. So first of all, we've got a special case here for 1 when we've got one item, but in here we're dropping the last one item, which if we've only got one item should give us an empty list to fold over. And so all I think we should be doing is finding the key for the last item, which is the same as the single one here. Does that make sense? I don't know. But if I take that out and run, that turns out to be okay. Although technically we haven't tested it, but we can test it by taking out this version here. Because if we remove this, all the tests we've got for 2 keys will end up with our vararg version. So we can get rid of that and run. And phew, we're still good. Now I'm not going to claim that that just came to me as I'm writing this. It did take a while, but now I think we can simplify things a bit. We can probably take this subject out, replace that with keys is empty, and maybe we should just augment this with a test for path of no keys. So if we duplicate this, let's say path of no keys, in that case it doesn't matter what we put in. We'll start with a property set that's big enough, but we'll say required nothing, which will compile because it'll go to our varargs version. And in this case we expect throws an illegal state exception if we do that with a message is equal to no keys supplied. Is that true? It is. Now it is possible to solve that problem a bit, at least the varargs version, by creating a version that always has at least one key. So we'd have key 0 effectively, which is a string, and then the others are vararg, and then if we took this one away, then this wouldn't compile. That's quite a nice trick, and we can make it work by saying that this is list of key 0 plus the other keys as a list, and maybe call that other keys. Is that true? Oh, well, of course it doesn't compile, and so in order to test the path of no keys, we'll have to give it an empty list instead here. like that. Splendid. So just a little bit of tidying up. We'll get rid of that commented out thing. I think this might be a little bit clearer without the types. Good. And finally, I think we'll just go back to our initial code here, our process data, just to check that we haven't actually broken the work that we were doing. Have a look at that, and you see that we're still extracting the name of the shop and the country that it's in. Wonderful. So let's check that in with add property set tests and extend to vararg paths. Good. So one thing to take away from today is just how easy it is to build data in data-oriented programming. We just have to nest mapOf calls. That's really nice. And the other is that with a little ambition, we can write some really nice general functions that extract data from data. Last week we were left with these things that we call data classes, wrapping properties, but they're only marginally data classes really, because their actual value depends not on this display name and country code, but on the properties inside here, if we were to compare to places, for example. So next week I want to pull on the thread of making these proper data classes so that we'd have something like data class place2, which had basically these two properties, and we know that one's a string and that one's a string question mark. And so find a way to migrate between this representation and this representation. See whether we can write some tools to allow us to do that. And part of my motivation for that is that this place here is hard to write out. It's hard to write back again as JSON or reverse to maps. So I'm looking for a way really of expressing a bidirectional mapping between a property set and a data class. I think that should be quite interesting, and if you do too, then please subscribe to the channel. Like this video so YouTube keeps on showing you the episodes, and maybe even treat yourself to a second copy of the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.